Um, all right. So, first of all, I have to say that it's really a pleasure to be here and see this amphitheater full of people, even in the morning hours. And it's a big thank you for all the organizational team, and I'm really honored to be part of that. So, today we're going to talk a little bit about applications of LLMs. We're in Greece, so I'm going to give a Greek twist. I'll start by saying that machine learning uses evidence from the past to predict the future. But today, I'm going to tell you a different story. Our research is about predicting the past, because without knowledge of the past, there can be no understanding of the future. And the value of knowing the past and learning from it was much recognized by the ancients, and as it is today. And today, it's studied by the discipline of history. So, I'm going to tell you a story about history today. And my story starts with the following. I was in Oxford. We had already done a startup in the second year of my PhD. The startup was absorbed by Google Deepmind. That was back in 2017. And I was going back and forth to Oxford to finish my PhD. My PhD was on machine learning and actually deep learning. And my favorite thing in Oxford was lunch. Andreas has heard me repeating that quite often. And the reason there was lunch is that you could sit down with people from all sorts of different disciplines and have a discussion. So it is like the amphitheater I'm seeing today, that you could have people from all sorts of backgrounds, from nuclear physicists to quantum theory to historians. That was the day that I was sitting with a historian friend of mine, and she was studying, she was actually an epigrapher. And epigraphy is the discipline of history that studies inscribed texts as evidence of the past. And these texts are called inscriptions. They're like the one you see up here. And they're very interesting because it's not history written by the ones who won the wars or by the victors, but it's actually first-hand evidence written by people themselves. So it offers a very good insight on the thought, the language, the society, and the history of ancient civilizations. So we're in Greece. Most of the museums you visit, you're going to find really lots of those. But truth to be told, they're really damaged because we're talking about stones that they were written 2,000 years ago, and they may have been used as pavements or they may have been used as walls, and the millennia have gone over them. Now, in the study of them, and while I was sitting with my historian friend, she was stressing how difficult the study of those texts is. And it's extremely difficult for three main reasons. The first one is that these texts are damaged, we have huge parts missing, and one of the most difficult tasks a historian has to deal with is restore these damaged parts. The second one is that these texts can be trafficked. Like, suddenly somebody comes out and they're like, oh, look what stone I found in my backyard. And you're like, no, you definitely didn't find it in your backyard. That was trafficked from a very long distance away. And the last one is that it matters a lot when it was written. Like, imagine the pandemic happened 5 years before or 5 years after. Like, the whole history we know today would have substantially changed by this tiny difference. So when the stones were written affects what we know of our past. But there's a problem here. These texts are usually written in stone, so it's extremely difficult to date a stone because radiocarbon dating obviously doesn't work. So we decided to create a model, like in that conversation, when she was describing to me these main problems she was dealing with, I was like, it was the moment that sequence-to-sequence models had started to appear, and I was like, maybe we could create an automated tool that could help you with that. She was like, no way. Like, there's no way we can ever do that because historians study these things for a very long time and it's extremely difficult. It's nearly impossible task. There are more data. There are not much data, and in general, she was like, no. But we ended up being like challenge accepted. And that's the story I'm going to tell you today. And because it's machine learning, we have to start with the data. And the data set actually is very interesting because immediately when she was describing to me all these problems and the fact that she was studying ancient Greek inscriptions, I'm Greek, like immediately I resonated with the problem. I was like, maybe that's a very interesting thing to tackle. So I started diving into what data there are digitized out there. And actually we found out, how many of you, are you familiar with Hewlett-Packard printers? Let me see your hands. Okay, fun fact. Next time you see your printer, Mr. Packard had created the Packard Humanities Institute, which actually digitized all of the known ancient Greek inscriptions. That started a long time ago. Like, it's a data set that probably existed for a long time in floppy disks, if you're familiar with them. However, was later uploaded online. So part of what we did was to scrape that data set and to bring it into a format that actually can be used by a large language model. Now the problems were extremely, I thought that that's going to be an easy task, but I was so wrong. And the problem is that historians, or in general, like people that don't do computer science, they're not maybe the most consistent when they annotate a text. So historians used to write lots of notes on those texts so that they can transfer the knowledge between them. But we had to filter all of those notes so we can feed to the model the raw texts. These notations were so inconsistent. So we ended up writing thousands of lines of code that were just regex matches, like string matching, just to filter out anything that was non-useful. Long story short, this was how the data set looked like. Like on the top, you see that there's the geographical metadata, like from where the inscription was written. Then you have all this weird strings that's like init siva, and that actually means that it was written from 400 to 350 BCE. So we had to do lots of conversions around this. And then you have the text that actually needs to be filtered out. We have to remove all those vacat, like all the additional signs. We have to convert that into a text that can be processed. Now, one thing that is interesting here is this one, which is they actually use, historians use this annotation of dashes so that they represent the amount of missing characters. And the reason that they know the amount of missing characters and they can usually estimate it is that, you know how you're in a computer's terminal and all the characters have exactly the same space so they align perfectly one below the other? It's exactly the same in inscriptions. Usually the character length is very easy to be estimated. So it's very easy if you have a line and the line below is destroyed, then you can estimate somehow like the amount of characters that are missing. Now, I like to visualize things because we had scraped all this data set and we were wondering like how big is that data set. But to bring it into perspective, this is when we're talking about large language models are trained on huge amounts of data. So in this case, I found this this description of like it was just some of the data sets that GPT-2 was trained. So we're talking about really long time ago. And if you convert the billions of tokens to words and then convert that to A4 pages, you end up with about 1 billion 4 pages. And if you put that on a book, that would be a 60-kilometer long book that ChatGPT is trained on. Now, to bring that into perspective, our data set was a 40 centimeter thick book. So the difference between the data sets was huge. And of course, like I'm trying to I'll try to simplify something that was like a very let's say long process of different experiments and trying to find the right recipe that would make everything work. So we had to do really lots of data augmentation. Data augmentation is a process that we do so that if we have little amount of data, we make sure that we change it a lot so that the model never sees the same data again. The problem is that if the model starts seeing the same data again and again, it will not learn to extract information from it, but it will learn it by heart and be like, oh, if I say this text, then I predict this. But what we wanted is to generalize. And to generalize, you need to be seeing all the time different information. So the first one we did, on the top you see a sample text. The first augmentation we did is that we would randomly clip parts of the text. Like we would throw away arbitrarily parts of text. The next one we did was text masking. And by masking is actually a funny thing, because when we started doing that, it was the year that the Transformers paper had come out of masked language modeling. But we had started to do masking a little bit before that, which was we mask parts of the text and we try to predict what was there. And that's exactly the problem definition and the problem setup that we're dealing with, right? Like we have texts that are destroyed. So every destroyed character is actually a mask. And we try to predict what these characters could be. So why I bring this up is that it was very interesting that actually by dealing with a real world challenge, we could actually get close to techniques that they seem to be state of the art today. We did lots of word deletion, sentence swapping, and other techniques. And we named the model Ithaca. And the model was named Ithaca after Odysseus' trip to go back to his home, because we feel that the same should apply to the texts. Now, the whole idea was about interdisciplinarity, and I don't want to say a story of another computer scientist saying that we solved this problem. I want to say a story about how computer scientists can collaborate with other disciplines and solve very hard problems. So it was really difficult to find a common language between historians and ourselves to try to communicate so we could explain what could be done, and they could explain us what the problem was. But it was one of the most rewarding things. And I always find it extremely fun to learn totally different knowledge than the one we would deal with day to day. So this is how our model works like. So we input a text, and the text is also inputted as both as characters and as words. And the reason is that we found out that we couldn't work at the token level. So we wanted, and characters are maybe too tiny in terms of what information they can hold. So words are the ones that actually convey information much more easily. So we chose to input both characters and words. And then we pass this to a sparse multi-head attention transformer. So that's an efficient transformer model like the ones that were presented yesterday. But because it's sparse, then you can deal with larger sequence lengths. And then we predict, we have 3 heads here where we predict the textual restoration, the geographical attribution, the chronological attribution, metadata of each text. Now, this is how our goal was not, of course, to make a single prediction and say that, like, yeah, this is the text missing, of course. But instead, our goal was to present to the historians as many hypotheses of what could be there or why could be there. So what you see here is like suggestions that our model, this is a text, and we hide this part, and then the model predicts the word simahia, which means alliance. And then 2 other words that were not right. Now, the question that we received immediately was like, sure, why? And what we did is that there are lots of tools that you can do analysis on like why a prediction was made. Of course, this is not causal most of the time. There's lots of research on that. But we followed the simple saliency maps approach. And what was very interesting here is that we actually presented the historians. When the word alliance is restored, we see where the model is, which parts of the input affect most this prediction. And we actually saw that the model is paying attention to the words Athenians and Thessalians, which is very interesting because it's the ones that actually formed the alliance. So nobody taught that model what ancient Greece was. Nobody taught that model what Athenians or Thessalians were. But by itself, by seeing many texts, I find it extremely interesting that they learn the moment they would restore the word alliance, it would pay attention to these words. Now, we also focused a lot on interpretable outputs in terms of geographical attribution and chronological attribution. So we give a probability distribution over the different regions that the text could have been written. And we also offer a distribution over the decades that that text could have been written. And again, we can use saliency maps or similar tools to shed light into that. For example, this is a text that refers to Commander General Nikias, who held a devastating defeat in an expedition against Sicily. And what is interesting here is that it shows the model page that when it's restoring the date of that text, the model actually pays attention to the commander's name. So the model has actually learned to pay attention to first names, it has learned to pay attention to places, and that's actually what historians do day to day as well. Now, looking at the evaluation, I think this was the most positive message of all, because we hear all these talks that AI is going to replace my job. And that's one of the, I think by scrolling in my newsfeed, that's something I get every single day. But truth to be told, I don't believe that. I believe that the majority of jobs are not going to be affected, or they're going to start using AI. And this was an example. Here, we actually measured the historian's performance that was on restoring text that was around 25%. Then we measured our model's performance, which was substantially better. But what we saw was actually when we measured the historians that use our model, they surpassed the model's performance and nearly tripled their own performance. And there's a beautiful message, pretty much saying that, sure, people that use more tools, they're going to benefit more than the ones that don't. We extended that research on region attribution, where we actually saw that we can predict with about 82% accuracy the top 3 regions. And we could actually date texts within 29 years distance from the date brackets that historians give. And I found that fascinating, because we are talking about texts that were written thousands of years ago, and we could still date them within 30 years. So we thought we should do a case study about that. And we found a set of disputed texts. These were texts that were redated at some point, that they had to do with, there were inscriptions from Athens. And there were inscriptions from Athens at the time of Pericles, Socrates, and some of the most important years of Athens. So even 10 years difference would change substantially a lot in the amount of history that we know. Now, what was very interesting is that it's not about, there was a debate from some more modern historians on when these texts were written. So we knew that our data set had some old dating values, but modern historians had published lots of work saying that no, this text should be written at that time. So we excluded those texts from our dataset, and we retrained our model on everything else apart from this text. And despite the fact that we knew that our dataset contained in general lots of noisy and maybe sometimes wrong values, when we asked our model to predict the dates of those texts, we actually found out that the model aligns extremely close within a range of 5 years with what the modern historians believed about those texts. While the dataset, the dates on the dataset differed by at least 30 years. What is extremely interesting here? The fact that you deal with noisy data, but you try to compress them using a model, actually seems that it works sometimes as a denoiser, being able to combine all the information. Why I find this interesting is that a historian usually will focus on a specific period for a specific place. However, the model was for the first time being able to see every single ancient Greek inscription written and make a prediction about that. So I'll do an intermission here. Because the talk is not just about ancient Greece, and I told you that it has a Greek touch, but the Greek touch is not just the Greek language, it's the Greek craziness. So while I was doing all this work, I had started working at Deepmind. It was I had already been for a while there, and I always wanted to do a PhD in cybersecurity. However, I never managed to get a scholarship at that time, and that had stayed inside me for a while. So when we were building that model, I thought that we had coded one of the most efficient sparse attention transformer models that existed in the Google code base at that time. That was extremely interesting because that meant that we had a transformer model that could handle long sequences. And when I was thinking about what other problems contain long sequences, I thought that cybersecurity is a perfect example. So I took exactly the same model that we used for ancient Greek, and I started feeding it in with examples of vulnerable code. So we would take code in C that we knew that it was patched, and we would take the source code before and after the patch, and we would ask the model to predict which of the two was the vulnerable one and which one was not. And all this using exactly the same model for ancient Greek. And as you can imagine, it didn't work. So, however, I kept on working on that on the side, and this ended up being recently published by the Gemini team, which is the Google's equivalent of ChatGPT, because we ended up doing the cybersecurity evaluations of Gemini using all that work that I had started there. Why I mention this is just to share that when you study machine learning, it's the beautiful thing that you don't have to limit yourself into one thing, but you can jump to all sorts of different fields. You just need to take lots of time to understand them, speak with the experts, and get closer to them. And another example on that was that I took all the knowledge that I had from training all these models, and during the pandemic, I felt very hopeless as of how much we know about the human body. So I ended up doing lots of contributions to the genomics team, where now instead of ancient texts, you had transformer models that were done on DNA sequences. This is the end of the intermission. We go back to ancient Greece. Now, to conclude this, we put the Ithaca model out because one of my fundamental beliefs about research is that it should be free and it should be available to everyone. And I think that is one of the most fundamental things when you're a researcher. Otherwise, you become just a product maker. So I think that we did lots of work to create an interface that's ithaca.deepmind.com that every historian could upload their text and they could get insights about the text. And what I find fascinating about that is that actually we've seen the adoption of that. I didn't believe, when we were putting it out, I thought that it's going to take really long time. We even had discussions sometimes with historians that when we were talking about our work, they would openly say that we don't value technology. However, it's beautiful to see the uptake of that, where today we see about 300 queries per week on our interface, and there are lots of crazy stories. One of my favorite one is one day, and that's one of the reasons I really like Twitter, is that you can get tagged on any sorts of random things. And one day I got tagged at a tweet of a teacher in Ghent, and I couldn't really understand exactly what the text was saying, but I realized that there were these students that they were that they were in a classroom and they were using a Ithaca model. And what I realized is that this teacher had created a curriculum that was about teaching AI and history together. So the moment they would go to the ancient Greece part, instead of just studying textbooks, they would have an extremely detailed syllabus that it would be full of exercises using our model. And I found that fascinating. I'd love to be that child that learns history and AI together. There's one thing for sure, that kid is never going to be a technophobe. They're going to always see technology as a tool to help. And today, because we've worked a lot with them, there are more than 80 teachers in Europe that they're using Ithaca in the class. To us, that's a huge success. At the same time, we start seeing lots of researchers using Ithaca. So there are papers actually quoting us, saying that they used our model to restore data encryption. And in general, I feel that all this has a huge potential in terms of it can be applied, like we've open sourced the model, it can be applied to all sorts of disciplines of text, like philology, papyrology. There were, for example, there was the Vesuvius challenge, if some of you are familiar, that you could actually use it there to restore some of the Herculaneum papyri. And it can be applied to any language. Of course, there are limitations, like if you go to languages with huge vocabulary, probably you have to adapt the model a little bit, and we're doing some experiments on that. But we think that the transformational impact that this work brought was huge in a discipline that some of the digital humanities have started to be taking off for quite a while now. And in general, we thought that like maybe it's very interesting to study that a little bit more, and actually all this work has been done together with some of the colleagues from our web, like Ion Andritsopoulos that gave yesterday a presentation. And what we did is that we thought that we should study everything that has been done around ancient languages and machine learning. And what was very interesting there is that we wanted to see how much the field is taking off, which it seems like there's a big momentum. But what we actually saw was that the best quality of work, maybe it's a little bit obvious, but it came from papers that the teams were interdisciplinary. Like they had both historians or experts of the relevant field and computer scientists at the same time. And we also saw that competitions really helped the field take off. So one idea here that I want to share that really struck in my mind was that maybe if you have a problem that you know that it's extremely difficult and maybe you cannot solve it, maybe putting out a competition about it, and places like Kaggle are amazing for that, can be a way to initiate research on that direction. Now, in terms of our work, we found a very romantic story behind it, which is that it's been about 150 years since the historian Schliemann discovered the ancient ruins of in the island of Ithaca, which is exactly the name of our model, and they were actually published in 1878. At that time, the young journal Nature. So Nature had just been founded a decade before Ithaca's discovery. So in our mind, we thought that we should publish our work in the concept of returning to Ithaca. So as I told you in the beginning of this presentation, with Ithaca, we used machine learning to predict the past. But then again, history has this uncanny tendency of endlessly repeating itself. So one could argue that Ithaca is just actually another way of predicting the future, showing us yet again how culture, history, and machine learning can be lastingly intertwined. Thank you for your attention, and it was really a pleasure to be part of this beautiful effort.
Hi.
Hi.
I wonder whether this kind of, in a sense, what you created is a generative model that basically creates new language sentences, similar, I guess, to ChatGPT, but I guess for ancient Greek, in a sense, like if I understood correctly, the must objective. I'm wondering whether this kind of data can be used in modern LLMs to enhance reasoning capabilities, for example, because I think that languages such as ancient Greek have so much grammar rules, syntax rules that can help on making structured arguments. And I'm wondering whether this is something that could help modern systems to learn to reason better.
So that is a very interesting question, and I love how all this data actually gives us like a magnifier to our past. I find that these models learn reasoning in through the data themselves, and maybe this amount of data is tiny compared to the amount of data that are actually trained. It's actually interesting because epigraphic texts are quite different from literacy texts. You can think about it, maybe a historian would attack me if they're in the rooms, I'm sorry, but you can think about it in the following way. Do you remember in the times that we had the T9 phones, like the ones with the pad, and we would limit the amount of characters that we would write because we would get charged if there was a second SMS?
Yeah.
Okay, I see a smile, so I guess you do. It's exactly the same with stones. When you write on a stone, you try to limit as much of what you write because it's very time-consuming. So the text differ quite. Imagine you read some of those SMS messages and you read some normal text. The difference would be quite a lot. So actually, we found out that combining this data with other data sets, like ancient Greek literature, doesn't help at all. I was very disappointed because I think I spent 6 months trying that and it didn't work. But that's the life of a researcher, right? Like you try many things, and one of them may end up in a good journal, and that's when it feels like the feeling is then amazing. What I find very interesting, though, and seeing your question from a different perspective, is I think that with this data we can study things in like there's so much study about bias in these models. Maybe we could try to study how bias evolved over time, because for each of these texts we have dates, we have the text itself, so we could study quite a lot of things in a very quantitative way that was never done before, and there are many ideas around that.
No, thanks.
Any other questions? The gentleman in the front.
Yanni, thank you very much for this impressive talk. I actually tried to log in and connect with Ithaca as we speak. And I tried to enter in a very well-known epigraph, the following one: Όξιν αγγέλιν λακεδαιμονής, ότι τι δεκίμεθα της. It requires 50 letters. I suggest that everybody tries that as we speak. And I stop at this, tis. We know the continuation of this epigraph, kinon rimasi pithomeni. And I realize now that he is trying to guess the next letter, the K, this kinon rimasi pithomeni. He gives 14% to the letter P instead of 3% to the letter, which is the correct one, kappa. You have to take a look at that.
But that's exactly what we want,
This
right?
is the first time I'm trying this, all right? I never tried that before. I mean, to connect to Ithaca.
And thank you so much for taking time to try it.
Oh, it's tempting.
But it's exactly what we want. We don't want to, like, I don't believe in making a single prediction and replacing the humans. I believe in making a set of predictions, and then by doing that, the humans can choose which one is right. The question is, like, quantitatively, how much do we study that, and how do we study that? So quantitatively, we've arbitrarily tried to hide gaps up to 10 or 20 characters, and try to get the model to restore them. And some of the statistics that we presented there were how well it does. We know that the model does much better always when there's much more context. So the longer the context is, the better the model is at restoring a text. So I'd be very keen to try that with a longer context. However, I don't have any beliefs in making a single best prediction, but more like giving to the historians a set of predictions and then getting them to assess that. Because it can be any word after that. Like, it doesn't mean that it's one single word. It's like when running Gemini or ChatGPT, you can always regenerate and you'll get a totally different result. So there's no one ground truth about history, but a human that can get all the context, maybe they can make the right decision.
Good. Any extension of this work to Chinese epigraphs or Arabic?
Spoiler alert. We are now working on it. We've been working on it actually quite a while on Latin. And we do have some colleagues that we've experimented with Chinese. It's very interesting because there you have a huge vocabulary compared to the 20-something characters that you get in Greek or Latin. So that changes the architecture a little bit. But also another interesting insight there is that in my mind, I thought that what we say in machine learning is like more data you have, then the model is going to become better. So I thought that maybe combining Latin and ancient Greek is going, because they're Indo-European languages, maybe there's some common structure behind it and that helps the model. We actually found out that combining more languages doesn't help at all. It's better to have, for these small data sets, it's better to have a model-specific one.
Thank you, Yanni.
Thank you, and for trying the model.
Other questions? Please, yeah. Wait for the microphone because I learned that this way the others together will get to listen.
There's a fascinating story about the deciphering of linear B in 1950s. Do you think that you can use this knowledge to decipher linear A?
You are in my mind in one sense, because one of the reasons that we did that survey trying to map 500 papers on whatever has been done around ancient languages, my single goal was that I want to learn more about decipherment. However, it's a little bit counterintuitive to how these models work, because these models work well when you have lots of data and then you can process them. In decipherment, it's exactly the opposite problem. You have tiny amount of data and probably all these models would be an overkill. So statistical methods like expectation maximization and with extremely simple models just seem to perform so much better. So I'm not saying that there's no way to do that. That's what research is about, finding way when everybody believes that there is no way. But I think that maybe these architectures are not the best fit for this specific problem.
Thank you.
I found interesting the word masking you showed before, and I would like to ask if you build a language model in ancient Greek to do that, or it's probably different method.
We haven't built so in one sense this is a master language model for ancient Greek. We haven't done a full training as of like what you would get with the equivalent of Gemini or ChatGPT to start generating text. We did think about it at some point because we thought that maybe we could condition on a time and a place and we could generate more data so that we could create synthetic data. I actually recently tried that even with dating so that we could arbitrarily generate some of the labels that our data set doesn't have. It doesn't seem to work well. Like in general, synthetic data in this it's a very difficult domain for synthetic data to work, I think. But again, there may be ways that we haven't tried and that may be a very interesting way to proceed. Because we have, for this specific reason, we've open sourced the model so that everybody can use it or they can try more ways around it.
Okay, thanks a lot.
Hello, thanks for the presentation. I wanted to ask about the masking. Like you referred that you can either mask the words or some letters, but there was an option about swapping the words in a sentence. I was interested how does that help the model, because like it changes the order someone would predict in a sentence. So how does that help the model actually?
So that's a very good question, because word swapping is one very common strategy and sentence swapping is another. So we actually found out that word swapping doesn't help at all because you break the task itself, like what would come after, while a sentence could be, like it's more common for a sentence to change it and bring it before another, and that actually we found that does help a little bit. However, it comes with a question of like, what is a sentence? in ancient Greek, because these texts don't have dots, they're all written in capitals, and there are no punctuation points. So all of these punctuation points were later introduced. And what we found out actually was that when we included those punctuation points and we tried to predict some texts, we found out that the models could pick up the trends that different ancient historians would pick to add punctuation, and the dating would be affected by that. So that meant that if I included the punctuation marks, or if I didn't, the dating would change, which is totally wrong. Like some dots shouldn't affect your dating a lot, but it's actually one of the problems that these models pick up all these different trends that maybe they're so subtle that as humans we don't think about them, but they can get substantially biased when they exist. And in this case, it was picking up this thing from historians. But yeah, word swapping, I don't think it's a good fit for this problem.
Okay, thank you.
Hi, very nice. Thanks for sharing. Thank you for your lovely presentation. We enjoyed it a lot. I mean, I have two questions. One of my questions is about your ability to date the epigraphy so well, and give us some intuition behind it, because it looks like, I mean, you have to have some theories on why you were able to predict and why those epigraphies have all the information in to reveal such accurate information about the date of these texts. And there's this other thing, this is very disappointing, not to being able to use the data of the Greek literature to do a prediction on the epigraphies. Maybe you should, using some compression, I mean, use the text and bring it down, summarize it to a fixed size, and use that as training tests for epigraphs, like create epigraphies. If you have this Greek literature, which is a lot of text, instead of 40 centimeters of the length, you could get something better by creating some artificial data out of the Greek literature.
So it was very disappointing for me as well. We spent really lots of time in trying that. We did actually try to arbitrarily, synthetically, shorten some of the words, like let's say with a probability X, we would shorten some of the words so we could get closer to the writing style.
Summarize.
But summarizing changes substantially the text. Like summary is usually something a human could read to, it's kind of a domain transfer that maybe if we had lots of data, we could train a model to do that. But in this domain, there's definitely not much. So we did synthetically try to generate such data, but then the problem is that the model doesn't learn from good ground truths, it learns from some synthetic ones that it would model the distribution of the parameters we chose rather than the actual distribution that exists in the text, which is extremely difficult to approximate, especially given the amount of text. Now, to get to your first question, so dating is a very difficult task on one side and very interesting on another. Historians would approach that by finding proper names in the text, and then they would see when the name Yanni appeared in what places and in what times, and then they would try to do an approximation to that. That gets us to, I think, around 50 years, I can remember the numbers, from the date brackets. Now, what we found out is that actually using, by seeing the texts differ a lot, okay? The reason is that they were written from 800 BCE to 800 AD. So in all this range, and all the places that they may have been written, the language substantially changes. So by learning features of the language itself, and that's why we wanted to also operate at a character level, or token level optimally, but we saw that actually the model is able to pick up all the subtle differences of the spoken language and be able to predict it much better. Now, as of why the bracket is so small, is that why the distance is so small, is that date brackets for let's say half of the text, the dates are a bracket maybe of 50 years. So there is a margin of error in terms of that, when could that be dated. But still for some we have extremely accurate dates that we see that they're very close, and those accurate dates may have been found because it was a tomb, and that text was inside the tomb, so we know exactly when it was written.
Please go ahead.
Thank you for the presentation. It was very interesting. I think I have a question about, it's a clarifying question. So you trained the model on the translation of the historians and the ancient characters?
We train the model only, thank you for the clarification, because if you have that, then maybe more people do. We train the model solely on the text that were written in stone. No translation, no summary, nothing else. Just operating on the text coming from the stone itself.
The pure text,
Exactly.
without punctuation marks and sentences?
Maybe some punctuation marks, but we have more recently removed all of them, and we try to get as close to the pure text as possible, still leaving some spaces so we can read it.
Okay. And I have a second question. You said that many other people took the model and implemented it in their own papers. They used it as a pre-trained layer so they can apply it to their applications, or pure the model?
We know that historians are using our model for their studies, not computer scientists.
Okay.
Like, we know some, but for me the most beautiful uptake is to see how many requests we receive per week, because all this is like, it's a huge cost, but thankfully we convinced Google to cover that for free, because it's still serving a large language model trained on a tiny data set. But these are the papers that I find the most interesting. Like, and the stories we hear, for example, one of my favorite stories was from a researcher at the National Research Institute, where they were studying a text that was, I think, for some women in a Greek island, and the model was predicting that was from Sicily. And later, like, looking more and more into this, and with a lower probability, it was predicting it was from Aegean Sea or something like that. And later, looking into this, they actually found that the family had connections with Sicily, and that's where they originated. So to me, these stories are the best. And if you know anybody that knows such story, that have tried our model and they've come up with such stories, we're trying to document them, because this is a motivator for this research to continue. And I feel that it's a very important path of research, like when we're looking at our future, to not forget our past.
Thank you very much.
So, thank you for your presentation. I would like to ask you this. For example, most of the texts have similar contents. For example, there are the historical texts about a historical fact. They could be orders of marble or clay or something like that. Couldn't you find maybe, modern texts about this kind of stuff? For example, orders about materials that can't differ that much from the ancient times, and maybe use them to pre-train the model on those kind of texts with missing words, and then retrain it in the ancient text? Because I think there is an application where you take an already trained model and you slightly readjust it or retrain it for your specific application.
So it has been in our minds, and one of the stream of works we had was we tried to fine-tune Gemini on this, because we're like, Gemini must have seen all of the internet, there must be much more ancient Greek than just the ones we have, like analysis from books, like all sorts of stuff. So we tried to fine-tune Gemini for this specific task, and it miserably failed. It was pretty good, but when I say miserably failed, compared to our model. And my take in this is that there's all this, like maybe buzz in deep learning of data and the more data you have, the better the models will be. And I've really started to, like through this line of work, and looking at this specific domain, I've really started to doubt that. Like I think that more data can be very beneficial when there's some connection between them. Even if that connection is the way is the syntax, the way we talk, and all these things. But when this data are disjoint and maybe there's only some weak connections between them, we actually found out that the model loses capacity into trying to model the bigger picture rather than the actual problem we need. And we've tried all sorts of ways around this, like sort of like curriculum training, like trying to play with the dataset mixture. We've tried to do at least 3-4 methods of multitask training, from uncertainty weights to PC grad to all sorts of ways. It doesn't work. But maybe it does one day.
Hi, just a minor point which is connected to one of the previous questions. I think one of the previous questions was mostly about why on earth don't you use all these large corpora of ancient Greek text? And I remember discussing this with Te at some point, and I think, again, the answer was that most of the Greek text online is literature text, which is very, very different from inscriptions. So, as you said, if you try to train on everything, then inscriptions are a tiny minority, and it doesn't work, I think.
Absolutely. And to this point, I have to say a huge thank you to Professor Andetsopoulos' team for being part of this project and for helping us carry this out.
I would like to add another component, if you like, to this discussion. And the component I'd like to add is that of ethics. And allow me to explain in a long and convoluted way what I have in mind. I remember as a high school student, long time ago, at least myself, the best way I learned to do research is through our ancient Greek teacher, who actually was giving us the ancient text and was not only about translating it, but also finding elements of civilization, politistica stοιχia, inside the text. And you alluded to that by saying that you're looking into semantics of what you find in here. And the next point to that is, okay, if we subcontract this to automation of LLMs, etc., definitely the elements of civilization we're going to extract are going to have certain bias, which comes from the data in which they have been trained, whatever these things have. So I was wondering, how do you incorporate ethics or concerns of this kind, of biases, in the discoveries that you make when you're looking into language and try to evaluate ancient texts and compose them and all these different things?
So there's an extremely interesting question, because actually there's one of the next things we would like to study. We definitely know that there's definitely substantial amounts of bias from all sorts of ways this text may have been written, but those biases actually shed light into the different civilizations of the time.
I'm talking about the bias of the LLM.
The bias of the LLM comes from the data.
That's right.
So
the way the LLM interprets the data.
Exactly. So that's the thing we want to study, as of like try to understand by these inductive biases coming from the data into how these models model them, as of like how we could shed light into different civilizations of that time. And also I find it very interesting on how biases may have changed over time. So we definitely do know that that is a problem, but it's not something I believe we shouldn't mediate, because it's the task by itself that that time there was lots of bias. It's today that we want to remove that from our models. But studying that and seeing how it evolves through time, I find that this data can be a unique opportunity to see how things change over time.
Okay, thank you. Is there a last question or a last couple of questions? I'm sorry, yeah. Go again. Here. Yes.
Hi. So just a quick thought. question, I don't know, comment. So maybe this could be, like I have heard of a problem where you try to find missing species, like missing, you have like, for instance, the humans, you know, there were like the Denisovans, there were different species, so there are sometimes missing species. So maybe you can apply this, I don't know, it seems like.
That is, I'm not familiar with that part of biology, but I know that there's lots of work, like when we did that in the survey, when they try to study the evolution of texts, that is something they would borrow methods from biology to do that. So what happens in most of literature texts is that a text was written once, or maybe it was even spoken, and then it was copied many times. And what we end up with is maybe a couple of copies that we find today. And the question is like, sure, they are all copied a little bit differently. What was the original one? So they borrow, or what was in between them. So what they do is that they usually borrow methods from biology to do that and achieve that. But I'm not that familiar with exactly the process. We just try to document the methods that are there, so we can inspire maybe more computer scientists to work in that direction, or biologists.
Okay, I think we exhausted you by now. Okay. So we thank you very much for all this wonderful talk.
Thank you very much. I want to thank my colleagues as well.